And we're live. Super special session, I guess you could say today, because I have Dan Shields here with me, my colleague, my cherished and dear colleague and friend, who you probably know mostly from in hanging out on the Substrate technical channel. And you do a bunch of other things. Dan, why don't you tell us a little bit about like what you do at Parity and yeah.
Sure. Yeah, I'm Dan Shields, or Nuke Man Dan everywhere, and I'm a support engineer here at Parity. So as much as possible, when you guys have trouble, I'm looking at Stack Overflow or our subport repo that's under the Parity organization on GitHub, or on our various element chats that we have in there. So if I haven't met you yet, please say hi to me. Feel free to DM me anytime if you have issues. But here today, I'm super excited to be talking with Sacha because I'm still very much, I would say, a Padawan learner when it comes to Substrate. I know a lot about it, and I know a lot about how to fix some of the problems that a lot of people run into, but actually implementing things is new to me. So I'm really excited to be the novice to ask the dumb questions today.
Yeah, and so there's another thing to say about the fact that Dan's here with me physically. That means that he's not going to be in the chat helping me and making sure that my mic sounds good or my video is good or whatever. So if you guys can help us out there, that would be super good. We do have two screens, and there is a screen with the chat, so we will be like taking questions and stuff as we go along. But we don't know whether it might sound muffled or anything, so just let us know.
Let us know, yeah. Tell us in the chat. You hear us? Give us a thumbs up.
Yeah. Can we get a thumbs up if you guys can hear us?
Yeah, please.
Thumbs up. Cool. So as we await your thumbs up, I'm going to kind of just give an overview of like what I had in mind for this session. And then we'll go into details, and I shared the slides that I'm gonna go over, and then the code also that we're gonna go over. The overview is that there's actually a global series hackathon happening right now, and this is for the APAC region. So actually, I'm hoping that a lot of you are here. Like, say hi in the chat. We're always friendly, and we always encourage people like saying where they're from and stuff. But so with this series happening, I wanted to just touch on like the basic things that if I were like starting with building with Substrate, or if I wanted to sort of try to make the most of building runtimes with Substrate, well, what are the things that I would think about, or things that I would leverage, right? So we'll go over that kind of stuff, and really this is also kind of for you guys. Like I want you guys to ask questions as we go through things. So I'm going to share my screen and just kind of get going. And Dan is going to also act as a student in the room, right? Like just how seminar really should be. So just give me a sec while I share my screen.
Yeah, and I like to ask questions, like a lot of dumb questions. So hopefully I won't interrupt you too much.
Sweet. So yeah, without further ado, let's just get rocking with this thing. So I call this Pallet Fundamentals. It's really not a great name because it doesn't mean that much. But really, what I want to highlight is like, what are the things that you guys should kind of like wrap your minds around as you're sort of starting to build things with Substrate. And what I assume that you guys already know is like what Substrate is. Like, so I assume that, if you're at a bar somewhere and someone says, what is Substrate? You can at least give somewhat of an answer. And same with Frame. Why is that? Because we're not going to go over like this, the things that the anatomy of a Substrate node, for example, is really kind of is a great way to start understanding Substrate. I'm assuming that you guys have already maybe started looking at the REST docs and are actually maybe already building a solution. So hey from Barcelona. Hey. Nice to have you all in the chat. A lot of thumbs up. That's fun. That's really cool. So what's the checklist for today? In doing this, I thought the first thing that I would want to share with you guys is like just how to set up your environment. How can you make your life easy before even like starting to talk about writing code, right? So that covers this kind of first part. And then the second part, we're really just going to jump right into like what are these key parts of a pallet that you can leverage. and we will be going through the how-to guides to do that. So for those of you who are part of the hackathon right now, we actually have a docathon track where we're trying to encourage people to contribute to our docs, right, and create guides as they're discovering like these things about Substrate that are really cool that we haven't maybe documented properly well enough. So the idea is I want to show you today what we have as guides and how they can be useful for you also when you're writing code. So then to finish on that, so yeah, the basic things, like in Substrate, when you're building runtime logic, a single pallet. So really, that's the unit of sort of that's more like one part of the runtime, right? A pallet is a runtime is made of several pallets. Well, a pallet is really nice because it's like you kind of know what to expect, right? Like it's well structured.
Right.
You know what the return types are going to be of specific types of functions, and you know what to kind of expect in terms of like how that pallet is going to interact with your runtime. So yeah, the guides that we're going to look at is the lockable currency one, and the custom origin. We're going to look at code that does custom origin stuff, but in the branch that I shared, we're doing a custom origin, but it's like a fake custom origin, I would say, because we're not actually using the origin system that Frame gives us. We are kind of using the philosophy or the idea of an origin, but not really like an origin as you would see in the collective palette and stuff. So we'll be actually looking at that code. So the first thing is like tips to like just get set up. So like if those of you are like new to Rust and you're just getting started, which is kind of what I'm assuming, there's maybe like, maybe 40% of us, maybe 50% of us that like are also really getting up to speed with Rust. In fact, there's probably way more. I know we also are getting up to speed, like always trying to learn more Rust stuff. But the Rust analyzer is super, super, super useful. And I'll show you in a second why. And then you can get this package. Do you have it also, Dan? The extension pack? Is that what you just?
I haven't used the proper extension pack, but analyzer and crates and TOML support, absolutely, and specifically for VS Code, right? That seems to be
this is true.
the IDE that most people prefer with Rust development. That's not entirely true, but most Substrate developers I know use this, or their core devs using some like NeoVim extra extensions and customizing things. But out of the box, this is definitely one of the easiest ways to get started.
Yeah.
I am curious, can we start a poll? Is that the thing?
Yeah, let's do it.
As we're going through this, you're saying maybe you're coming with a Substrate background or you're coming with a Rust background. How many here, I'd love to know in a poll, consider themselves like Rust experts, or are they more Rust novices? They might have just started to learn Substrate and Rust together. That's a very common path.
Are you more of a
Rust or Rust background, or maybe a bit more of like a Substrate background, or just new to it all and here to learn? I think in particular, this is great for people who are new to Rust and Substrate. And VS Code plus all these extensions, super helpful. Absolutely.
Person knowledgeable in Rust. And then
I know today in some of the stuff that we'll get into, because I got to preview it a little bit with Sacha, is really more Rust specific. Some of the power that Rust gives you in the context of Substrate. Like Rust is a very great systems architecting tool, right? It's a systems really language in a lot of ways. So we can make really complex systems in an abstract way, and then actually concretely build these things based on all this logic that we put together. That's kind of how I view Substrate, right? Is that this is an extremely powerful tool set where the logic behind how blockchain should work has been done for you, but actually linking the things together is up to you. And that's what really we do with Substrate, is compose all of these powerful tools.
Yeah. So we'll go into that stuff. Just real quick, there's a question from Stan. I'm just going to answer it right now because it just popped up. Well, the question is there like a crates.io just for pallets? And crates.io is a package management, like generally speaking, it's not specialized for anything in particular. You will find a bunch of pallets that are like frame pallets, right? So these are pallets that are developed by Parity Technologies. You will also find like some open, there's this thing called ORML, right? Open Runtime Module Library, originally developed by the guys at Laminar, Akala, right?
Yeah, I think originally, yeah.
Yeah,
It's open to the community.
and like again, you can Google. I mean, sorry, you can search ORML crates.io and you'll find it in crates.io. But there is no like organized way. That would be my answer.
Well, there is a bit of a sneak preview for you guys. There's a thing called Marketplace that's been worked on internally, and pretty soon this will come out as a place on the Substrate website where you can browse various pallets. And I believe we use a scraper to figure out what's on GitHub and what's on crates.io. That's probably Substrate related. I'm not sure exactly how that's implemented, but there also, I'm sure we can talk about if you guys have suggestions for a convention, something that we could use in crates that makes it really easy to identify. And then there's other ways to browse crates, specifically looking for substrate-ish stuff or cryptocurrency-related stuff, like libs.rs, lib.rs, I should say, has a cryptocurrency subsection that has a lot of our stuff in it, for instance.
Yeah, cool. So I want to just show you live like what I mean by just these tips. So the other one is Git lens and Git history. And I didn't mention it vocally, but you can see on the slide, having a local copy of the actual Substrate source code is incredibly helpful. It's really helpful because it allows you to see like all of these traits and stuff that you can work with when you're developing your runtime logic, but to see it in practice, right? Like Substrate is a bunch of like heavy lifting primitive libraries and crates, but then at the top you kind of have this really nice thing called frame, where there is available to you pallets that do the things like the consensus layer. It does the balances of a node, and if you look at other chains, you will find examples of like how they've used Substrate. And yeah, each palette is its own thing. So it's super helpful because you can, if you're making something that's similar to the governance palette, well, your best bet is probably to check out Parity's governance palette, only because like these are the guys that are doing the real like engineering and they have thought about it. Like this is kind of like the best example, right, when you're coding, I think. So so right now I actually wanted to show you what it would look like. So first of all, I have, let's just see what my my extensions are here. So if I go extensions, so I have better toml, I have crates, I have Git history, super useful, right? Because like, for example, if I'm looking at, what happened, or, about, I don't know, on initialize, for example, so we can see like Guillaume, who's one of the Rust and he's working on frame mostly, but he's a Rust expert. Kind of, we can go to the actual PR that justified that decision, right, and understand why is it that way, right? So here there's just a migration PR, so probably nothing too interesting. But really, I would say a useful tool if you as you're developing with Substrate to kind of like get comfortable with all this information that is really at your fingertips. So if I go to the balances palette right now, and this is a little too big maybe. So what's great with now just looking at the Rust analyzer, well, if I'm not too sure, for example, what this what's a good example? What should I look at? Like if I'm not sure that, okay, this existence requirement enum, where is that coming from, right? Well, I can see that it's from frame support, traits, and some module called some miscellaneous. So I can even click. I can see the implementations of it too, right? And we'll go a little bit more about what these concepts are. So please don't get intimidated. I'm just trying to show you that this tool really like helps you understand like what's going on, right? Like Rust is a very is a language that handles layers of abstraction and complexity, so you can kind of get lost. Yeah. One great one is the balance one, right? Like, so it's this enum, and I can click on where that is in the source code.
And so for those who are watching, this particular hover and you'll get whatever it's coming from dependency-wise comes from Rust Analyzer. But I do see a question in the chat, and I also get this, where you'll have 100% CPU. It's a really heavy process to run Rust Analyzer. This is because it's actually building all of Substrate. And it's I think the single largest Rust library there is in existence. So when you compile this thing, it's big. It's actually benchmarked against in the Rust community, Substrate, and specifically Cumulus beyond this, which is an even bigger thing that uses Substrate. So I don't know off the top of my head actually how to disable some of this debugging and checking that goes on in the build in the backend. If somebody knows, please let us know, because that could help a lot of people that just want this functionality. Just an easy way to navigate around straight types versus having all of this integrated debugger, because that's the thing that's eating up your processor.
Yeah, thanks for that. So just to finish on like how to navigate having the local copy of Substrate as a sort of tool. So just again, guys, so what we're looking at here, you can maybe you can't see it because the screen is too big. Can you see at the bottom? So at the bottom, yeah, you can see it. I just can't see it on my screen right now. But this is the latest master from Substrate. So if you go to the repository, Substrate repository, just clone it, and just keep pulling. Just make sure it's up to date, because there's a lot of changes that happen over time. And yeah, this is just a great way. So just to finish, like on navigating this thing, well, essentially, in Frame, you'll find all of the Frame pallets. There was a question about pallets and where they exist, and my answer was, that there's a lot of different organizations at this point developing pallets, which is really cool, right? Like, and they are using Substrate, and I think a lot. Like, I haven't seen an implementation that doesn't use Frame, so Parity Technologies is one of them, right? And this is where their pallets live. So you have the Bounties palette. It's I think implemented in Kusama. You have all of this consensus stuff, Babe, Aura, and Grandpa's in here, I think, too. Yeah. So again, like a great way to just jump in and see what the examples look like. And we'll be doing a little bit of that as we kind of progress. But that's the first thing that I wanted to show you guys about the benefits of having Substrate in your on your local machine. And the second thing is, in this bin folder, you actually have access to exactly what the runtime looks like after compiling all of the pallets in Frame. So this is used to kind of do testing stuff, and so it's always going to be up to date. And if you go here, for example, so by the way, it's bin and then node. I made a mistake. The node template is just what you have as a node template. So if you go to runtime lib.rs, and I always like to do just define that construct runtime macro, because it brings you immediately to where all these pallets are. So you might looking at this kind of looks different from what we're used to and we're going to be working at, because there's a PR that you can see right here that came in two days ago. It was merged, where it's a kind of just it's a really cool thing on this. It's just like this whole thing of we're continuously trying to improve the developer experience for those using Frame. And Guillaume is a huge big shout out to Guillaume, because he's a huge contributor to that. So that's why it kind of looks different. I invite you to read that PR to understand more about it. But yeah.
But so for context, the node effectively is everything that Substrate provides. I think there might be a few exceptions of all pallets that can be composed together. Like you can't, for instance, use Aura and Babe together, because the block production, you have to pick one, right? So I believe this one is using Babe, whereas the node template is much lighter. And this is actually what you'll see on the Substrate Developer Hub is the Substrate node template. It's exactly the same code that's there, but it's ported over, at least right now, on a monthly cadence. So anytime there's a monthly release, this will be ported as an independent repo for you guys to use, so you don't have to pull down the entire Substrate library just to play around with a new node. So just a pro tip.
Yeah, that's definitely a great point. So yeah, we talked about that. Okay, so I picked like for me, what the most important things are when we say, why Rust? Why are we using Rust? And really the question for me more is, how is Substrate making use of why Rust is such a great language? So what I picked is, well, the first thing, the trait systems is something we need to understand. So I've seen in the chat, some of them are some of you guys are beginning in Rust. So that's completely cool. Like, this is the point of this slide. This is the point of like where, and like I am too. But the point here is to just kind of give a highlight of what these key parts or sort of characteristics of the Rust programming language. So I took this from the Rust book. This is literally copy paste. A trait tells the Rust compiler about functionality about the functionality a particular type has and can share with other types. We can use traits to define shared behavior in an abstract way. We use trait bounds to specify that a generic type can be any type that has certain behavior. So if you read this, you probably think to yourself, like, okay, what's going on? Like, okay, a trait. I mean, I think the takeaway is like, from reading this at least, is like, Rust is trying to handle behaviors defined by layers of abstraction. I mean, it's really like a language that has a lot of power in handling these different layers of like multi-dimensional layers of abstraction. And so the trait system, really, though, for those of you who are coming from like more C++ or other languages that call these things interfaces, right? So trait really is an interface. It's what you can expose sort of without duplicating code. You can really like leverage the idea of abstraction that traits and interfaces provide us. But in Rust, we call them traits.
Yeah, and in Substrate, actually, this is one of the core pieces of the library itself, is a whole bunch of trait definitions. So this basically takes the mind game of how do I build a blockchain and codifies it in an abstract way, right? We write all the traits, that the things that you need to satisfy to, for instance, we'll go over like a block header. What is a block header exactly, and what are the components that need to be in it, without actually concretely saying what those things are, right? Because we, as the runtime designers, might want to use a different type of like a primitive type, right? If that block header has particular information in it, maybe we want to store it in a different primitive, like an integer type, right? Something like this, right? So Substrate, mostly that's what it's about, is setting up the blockchain architecture for you, and you just have to make sure it works. The Rust compiler is powerful because it double checks you, make sure that you filled in all the stuff that you need to.
Mm-hmm. So this is just an example of, well, I actually want to wait, I want to kind of like show that this is like not just an example. The reason I chose this code is that this is where the business logic from your pallets it gets composed into what we just know as the runtime, right? And all it is, though, in terms of Rust programming language, is it is implementing the configuration trait for the runtime, for a struct called runtime. It's an enum, actually. So this runtime enum has a little bit more complexity than if it were just a normal enum, because it's actually being passed into this construct runtime macro, and it's the macro is probably like has a very specific way to implement this runtime enum. This is why you don't see it as like typically what we're going to be seeing when we look at the code. So yeah, it's a trivial sort of like way to sort of use the generics in Rust and the traits in Rust. However, it does a lot of heavy lifting for our use cases. So trait bounds. So trait bounds are this other really powerful thing, right? Where like you can define a type based on how it's bound by these other like heavy lifting, or some not so heavy lifting, some more primitive things that will actually just define the behavior of that type. So yeah, that like so for example, this event type that we all have seen in the node template, the template palette, and every palette has an event actually. So this event type is taking all of these specific traits, right? Yeah, so we call this concept bounding a type with traits. And so the third thing is generics. So super important concept where Rust it gives you a lot of flexibility and power, is to use generics. If you look at the code in any palette, the palette is just a struct that has implementation over a generic type T. And that's how we managed to aggregate all of the knowledge, the business logic and the extrinsics and all the functions really in that palette, and it gets exported to be then put into the construct runtime macro. But it's really the power of generics is used but so heavily in Substrate. What do you have to say, Dan?
Yeah, so you'll see down at the bottom this config. So we're specifying that this generic type T must have the trait config. And this is actually how you'll see we pass around effectively this object that globally exists as this config thing, right? So this is what we're doing for the palette. We're effectively saying that concretely, this specific generic needs to have this config trait, and we actually go ahead and implement that concretely elsewhere. So this is why you see it everywhere. We have to hook back effectively into this core component of everything.
So the Rust programming language introduces this concept called metaprogramming. And really, the concept of itself of generics feeds into what we're talking about when we say metaprogramming. But Rust really is a programming language where you can abstract pieces of code where you don't need to rewrite them, but they are just working in the back essentially. And that's where we say this a lot, it's just macro magic, right? So the concept of a macro really sort of gives us the tools and the power to do metaprogramming. And we use that a lot in Substrate because it does a lot of it introduces much more efficiency in how we can program things.
Yeah, these macros are to make your life a lot easier. Stuff that you would otherwise have to write out manually and implement yourself manually, it'll get for you. So like this implement runtime APIs, for instance, it does a lot of things in the back end that otherwise you would have to understand and then actually write. But because we know, because of these powerful traits primarily, what they should have, we can automatically implement these for you on your behalf. And these the declarative ones, I know that this gets a little bit funky. The syntax is whatever we want it to be. So it looks like Rust, but it's not quite Rust. This is why we've actually deprecated using these in pallets. They used to be the decal macro, if you remember those. And now attribute macros, though, these are more decorations in the sense that I put them as an indication that I would like the compiler to, in the next segment, add a whole bunch of auto-generated stuff, but just understanding that that's in that context. So it's not a domain-specific language of any kind or something weird. It's proper Rust, and this just adds extra functionality that you don't have to think about.
Mm-hmm. Yeah. So so before we kind of move on more specifically on pallets, if there's any questions on that, we'd love to take them now. And what I hope that these few slides on Rust and Substrate has taught you is next time someone asks you well, why Rust or what is it that's special about Rust and why we're using it, I think at least you could say a few things, right? The concept of how we use traits, the concept of how we can abstract logic with generics, and also this really powerful thing that we call metaprogramming. But so there is a question, but I'm going to leave that for the end, just because it's a good question, but it's not really on track with what we're trying to kind of teach and share with you. Okay, so pallet functions. So so in a pallet there is 3 types of functions, Really, there's three types of functions in a pallet. The first is the obvious one, right? It's what anyone can call from outside the chain, and that we know them as extrinsics, right? These dispatchables that we need to be very careful when we write, because anyone can access them, right? Anyone that has access to an account can try to make a call to these functions. So that is why they're not just like your usual functions in a pallet where they are prefixed with this wait attribute, and also the pallet call attribute does the sort of macro magic to tell the runtime that this dispatchable is one that is public and exposable by the chain.
Yeah, all that extra stuff that you would need to hook it up to make it public, I believe that's what pallet call does.
Yeah,
right.
Yeah, exactly. So the two other ones, it's when you're building a dispatcher, when you're building a function that's publicly callable. Well, inside of your pallet, it's always nice to maybe offload the code into some helper function, for example. This could be, for example, you have multiple extrinsics that want to mint an asset. Well, why would you rewrite the code in every single extrinsic? You can just call the mint function of your pallet to achieve that, right? And the mint function in your pallet is not a publicly exposed function in the same way that an extrinsic is. It's a function that is accessible to your pallet. So there's two types of these, right? There's one that can be, so one would be private. That means just a helper function that is not accessible by any other pallet in your runtime. The other one would be a function where you could actually use it in other pallets, right? And this is just Rust stuff, right? Okay, so we've kind of just done the sort of like the Rust and Substrate stuff, the basic pallet stuff, which actually have two more slides. I think I mixed them up a bit, but we're just gonna go just cover this real quick. I would say these items are also very important when you're building with Substrate. The first is the scale codec system, right? This is how the entire sort of interface of basically encoding information with sort of using cryptographic primitives that Substrate nodes understand, and also having an interface to decode that information so that it can be understood by UIs, right? And like more like sort of user-facing applications that really need to understand this. And why it's important is because that means that every single thing that comes in and out needs to understand this concept of scale codec. So I invite you to read on that. I invite you to understand why it could be interesting for your applications to maybe know how to work with it a little better.
Yeah, so as I understand it, scale is how we store things at the fundamental level. It's a hyper compact codec encoding, in the sense that we'd like it to be able to be used anywhere on any device, and be as efficiently stored as possible, because we're talking about blockchains. Blockchain storage is unbelievably expensive. So this really helps facilitate that. Unfortunately, it is just effectively doctored up binary, right? Mm-hmm. So abstracting things like a string versus some really crazy struct or something like this, it has to go in and out of this very much more, I guess, down to the metal level of the storage. So getting in and out there is what scale enables you to do.
Yeah, and so actually, I got distracted because I'm reading some of these questions. But like real quick on the other 2 points is like Substrate is a gigantic beast of libraries of really like I'm biased. I'll use a biased word, like intelligent code that does a whole bunch of things, right? And really, when you think of it in terms of crates, right? Really, Rust is just a collection of crates. Well, it kind of starts to be easier to understand the picture, what's going on, right? Mm-hmm. You have primitives, you have like client libraries, and this includes consensus stuff. This includes like maybe like finalization things and on runtime upgrade. But then you have sort of frame, which is like a really nice, great, easy way to make use of these heavy lifting things. So just I invite you to like check out, what are these different crates? SP underscore IO. What is that exactly? What's SC whatever, right? So these are these crates, and I think just sharing with you like helps sort of get a picture of what's going on.
In my mind, I think about the runtime as kind of an a la carte thing. Although a lot of the times when we talk about Substrate, we really like to build a full blockchain and customize very nitty-gritty things about it, like in the consensus layer, or in the networking layer, or in the storage layer, right? So primitives and client create libraries, and where you're implementing in the runtime, I should say where you're implementing them elsewhere outside the runtime, can become a lot of very important. They're also seen in the runtime, but it's more, it's not quite at the level like you're talking about consensus. Yes, it's component of the runtime there, but lower down, if we need to have that affect storage in some way, then we might have to break out of this runtime and go into your node composition. So the /node/source.
Yeah.
And then pallet macros primarily are associated with the pallets. What do you know? So frames.
I shared the link of macros. It's kind of interesting, for those that want to like take a little deeper dive in the unknown, to look at how it happens under the bonnet. There's a question about what types of macros are available and what are more commonly used in the current state of Substrate. So like I indicated here that these are the most commonly used types of macros, but really we use all types of macros. But I just pulled these out, and by no means is this an exhaustive list of the types of macros, but the most common macros that are used, and especially the ones that we will be seeing today, is declarative macros. So that's the construct runtime, and attribute macros. So that is this frame palette attribute macro that gives us access to when you say palette config or palette call, palette event, palette error. And
if you're looking for where it's implemented in Substrate, I forget the exact syntax, but if you're looking for how they declare and define these macros, you can search for those. That macro is something or other. You'll find it in there. And if you guys want to ask in the chat later on, I should say on Elements chat, we've got a Substrate Seminar channel, I think. We can discuss some of this, and we can point out later where those live.
Cool. Okay, so I guess we have to kind of so Pallet fundamentals, so this is kind of what I want to kind of look at. We're not going to look at Genesis config. We're not going to look at weights and stuff, but I do want to show you what it looks like, in the sense that that we can look at code that already exists. It won't be on the branch that I shared. The functions and return types was this last piece on what does a function typically return? Well, it'll either be a result or this concept of dispatch result with post info. So I actually have a slide on this. And the reason of this slide is I hope it's not too aggressive for your eyes. It's kind of weird looking on the screen, but if you have a doubt on what is dispatch result with post info, just check the Rust docs, right? And it's a great way to understand which one you would want to use for your use case. Typically, we use dispatch result with post info when we're basically so the definition is the return type of dispatch in frame. When returned explicitly from a dispatchable function, it allows overriding the default post dispatch info. So it's kind of an efficiency thing used to do something to do with weights. So if you look at the documentation about post dispatch info, it's really like a refund on weights. And the reason that it's in the code for the stuff that we're going to look at today is nothing more than that's what I was rolling with. But we could have used dispatch result, and also the palette that we're using that we're going to do with lockable currency. It's not nothing production ready, so it's not as an engineer my concern right now isn't to optimize on little nuances like this. Okay, so before we do that, let's just quickly look at a palette that exists in Substrate and how it's also kind of what other folders it lives with. The reason is because weights will become you will understand what weights is, and also some of you that are kind of beginning and looking at these examples as references, you might be wondering, why does my template node palette not look like this, right? So I just want to, I thought in preparing for this, like that they would be useful to just go over that real quick. So right now I go into the frame folder of the Substrate repository that's locally copied on my machine. And well, a good palette is the example palette. I actually have it already open. So if you look carefully here, you see that there's a benchmarking.rs file and there's a weights.rs file. This is because the weights I gave a seminar on this a couple of weeks ago, but the way that we can optimize on choosing the right weights is by doing benchmarking and basically deriving like the exact values that correspond to the benchmarks for extrinsics. So that's why all these files have weights. In our example, we don't even have this file. We're hard coding a weight, and benchmarking.rs is sort of the logic that you want to sort of put together to enforce and to sort of stress test your extrinsics to get the right weights. There was a couple more things on that slide, and it was the use of hooks. Hooks are very interesting and positive and sort of hooks are a very unique feature of Substrate. Hooks allow you to define some sort of logic that gets executed at every single block if you wanted, right? So if I go into the documentation for hooks, I go into the traits. I used to be able to just go here. You know what? I'm gonna just do it like this then.
And it's directly in the rest house.
Yeah. So why are we doing this? Well, because hooks give you this capability that, as somebody who is wanting to sort of build with blockchain or build a blockchain, or even like if you're a smart contract developer, if you're a smart contract developer, you don't have this flexibility. You don't have the ability to add some logic at every single time that the block is executed without having sort of an on-chain second layer, and then you need to pay transactions or whatever for that. Hooks give you the ability to do this at every new final block. So this is the hooks trait. So for example, if I wanted to implement that at every 100th block, something happens, and that thing is I increase the supply of tokens, or that thing could be I tip out a certain group of account IDs, right? So certain members in a committee. Well, I can use this, right? So but there's one thing to be said is you can't use it for anything. I mean, you need to be thinking as a blockchain engineer here. What is something that is lightweight enough that it wouldn't affect the block execution time if I put it at the end of every block. However, this gives you a lot of flexibility for your logic. Yeah.
So it's an interesting question about hooks, right? Because when I think about pallets, I'm thinking in the mind space of a smart contract developer, where I'm providing functionality that anyone can call within a block, right? So all of these callables that we define in the pallets, those are typically, in my mind, right, things that can be executed at any time, but probably not all the time in every block. This is an abstraction below it and says, for this particular package or pallet, really, that we're putting into our runtime, this always has to happen not based on user input, but based on simply that the blockchain is running, right?
Mm-hmm.
So it can be a very powerful primitive that, for instance, why you might choose smart contracts versus Substrate. You can't do this in smart contracts, or at least nearly as easily. Maybe you guys can tell me if I'm wrong.
Yeah, so I just searched on finalize, for example, which is one of the functions of this hook trait, and it's used in a bunch of places. It's used right now. We're looking at the authorship palette. Let's see where else we can find something on finalize. This is the example palette. Oh, this is some old stuff. But yeah, anyways, I hope that. Oh yeah, for example, just print something. I don't know, right? Yeah, so the hooks part of your palette is really this capability where you have these functions that you can use and define some custom logic. There's one last thing I'll say on hooks is that the most common use for them is for storage migrations. The most common use is to ensure that that some logic has been executed and then sort of make the transition. I mean, we're not going to go into storage migrations today, but hooks have more of a utility value than a sort of feature value, I would say. Yeah. Okay, so where was I? We talked about hooks just now. We were talking about. I wanted to go over Genesis configuration, and I guess I lost where I was. It doesn't matter.
So maybe back in the file explorer.
I'll just look. Where was I? See? Yeah. So hooks, Genesis configuration. Oh yeah, we talked about weights, and constant. Well, I think it's already. Yeah, it's probably just a good point to a good place to just migrate into going through the commits and why and looking at the currency trait.
Sure.
Sounds good. Okay, cool.
Did you want to go? I guess Genesis config is worth looking at real quick.
Yeah. Okay.
So back in the node template, for instance, if you look at the files, that are included.
Should I just go in the substrate repo?
Sure. In the node so I know the template pretty well.
Yeah.
So if we go in the node template, in the node specifically, now under source, there's a whole bunch of things here that are defined. Chain spec is the one that's most tightly coupled with your pallets, right? So looking through here, one thing that you can point out is if you scroll down effectively, you will see a whole bunch of things that are being declared and defined. And then really here is this this development of the WASM binary, right? So we're saying when we want to make a chain spec, we're specifying some of the initial parameters on Genesis, right? Hence, this is where this is from, Genesis, that want to be defined. So like, who are authorities, for instance, when we're running a proof of authority network? Well, we specify that in this case, the development seed, Alice, right? And we can also endow accounts. And this is effectively how on Genesis, we can mint new tokens from nothing, right? Because we're starting from the beginning to particular accounts. So, but this is specified in your pallets, right? Your pallets have no sense of state. They only know how to change state. So this is the initial seed state that gets plopped into your pallets.
Mm-hmm. Yeah. So essentially, if you we can kind of go into this real quick. I mean, when you want to configure an initial state of your palette, like you basically you have to come here to actually specify what it is, but also in your so if we go to pseudo palette, let's check out the pseudo palette. See how they do it. So basically, we're looking for the
pseudo palette. We want to be up a level. We're in the node.
Yeah. Okay. Yeah. I want to go here. So if I go to pseudo palette, I'm basically looking for the Genesis config. So then Genesis config. So
we got to pass it a key.
So it's really just using the macro and basically passing in the key to the Genesis config struct.
So this is what we know in here. This palette Genesis config macro is behind the scenes implementing a whole bunch of things so that in your chain spec you can actually just then set this. You can drop in the concrete value that you would like it to be on Genesis.
Yeah. Yeah. I mean, that with the new way to write with Frame v2, there's sort of, this would be the code that is doing Genesis configuration. You need to declare it, and then you need to build Genesis. So yeah. Okay, so that is good for that. Now we can kind of go into this. And I want to hit specific points. Yes, I know what those are. Is there any questions here?
And as we're moving through, please do use the ask a question.
Yeah, guys, it's hard to keep track because I'm seeing questions.
Questions in the chat are useful, but they get lost.
They get lost.
Use the ask a question box.
Use the ask a question box. It'll be much easier to keep track for us. So where were we? We were kind of saying, yep, there are these kind of like key things in the palette, right? But we're not going to talk about all of them. I mean, in terms of like hands-on stuff. But what we are going to talk about is implementing the lockable currency trait. So this is just a screenshot of the Rust docs, and as you can see, we have access to all of these types of all these traits, and the one that we're going to focus on is the lockable currency trait. Yeah. So what's fun about doing this with you guys right now is that what I did is I used, so if you head over to substrate.io/how-to guides, there's a bunch of guides in there. And like what I said in the beginning of this, like, the list of guides is by no means exhaustive and by no means complete. We encourage those that have maybe some experience and that are running into interesting problems and finding interesting solutions for them to make their own guide, or at least create some sort of like idea for a new guide. And you could just make a PR, or you could just raise an issue in our docs repo. But yeah, we encourage you to do that because it's also fun to write a guide. You learn a lot. So in this guide, we're actually just going to use this guide. It's called Implement a Lockable Currency. So what's the goal of having lockable currency? Like if you were designing a system and you were looking for something where maybe there needs to be sort of a hold on some funds, right? Well, this would be a great use case for a lockable currency. So the use case would be staking. It's incredibly used in the staking palette, and it can be used in like a lot of other scenarios where funds need to be held and locked.
Yeah. So in coming from like a smart contracting idea, that maybe conceptually I would think of writing a contract that would be effectively an escrow contract that would hold funds and under certain conditions could release those funds. We're extracting that down to actually just in the same account effectively. We're locking those funds so they're inaccessible. And then we get to write custom logic based on those locks when those can be undone. So like in staking, right, for instance.
Mm-hmm. Yeah. So again, what we're doing here is super, super simple. And if I were to like kind of come back to this and be like, oh, I want to make it more interesting, one of the first things I'd do is to see how the staking palette does it, right? Like, what is the sort of like logic that it's borrowing, and yeah, I do want to say actually that like give a shout out to like the team that was working on recipes, which used to be the version of this what we now have as how-to guides, because this was a recipe. This was just a really like great like learning tool to understand how to use this lockable currency trait. So I'm just kind of scrolling down this just kind of for you guys to see the extent of this of what we're going to be doing. So I mean, it's really not that long, right? Like I'm already at the bottom, but it does expose some very interesting parts of building with Substrate and using the APIs that are available to us. Mm-hmm. There's a couple other guides though that we're going to check out. So basically, this concept of tightly coupling things, right? We are going to be doing some tight pallet coupling to some extent.
So what's the difference between tightly and loosely coupled pallets?
So what is the difference between those two? So essentially, the difference practically is that you have a lot more flexibility with a loosely coupled pallet, right? If you're tightly coupling a pallet, this comes from like a concept in computer science, where the more coupled pieces of code is, the harder it is to sort of make that code extensible, because whenever you want to extend that code, you also need to extend the other code that it's tightly coupled to. So in Substrate, really, it's just a matter of engine or design decisions where there might be good cases to tightly couple things. So for example, the treasury pallet is tightly coupled to tipping and bounties. There might be good use cases, but generally speaking, like, you have a lot more flexibility with loosely coupled.
Yeah, so loosely coupled, I think about reasoning in that it's a powerhouse of Rust, right? Is that you're abstractly defining a pallet interface to some other pallet that must have certain traits about it, right? Whereas tightly coupling a pallet, you're relying on a specific implementation of a pallet, right? So when we tightly couple something, it's specifically relying on, for instance, the balances pallet. It would be only this balances pallet can work. Otherwise, you got to change them both together.
Yeah. That's a great way to put it. And like the outcome is technical debt, right? You know.
So it's a little bit harder to wrap your mind around, but loosely coupling is almost always the way to go. I think there's a little tip on the overview about tightly coupling that says you probably want to loosely couple your pallet instead.
We have a lot of questions, actually.
This is cool. Maybe we should go through some.
Yeah. So Alexander asks, how can I use the lockable currency from within an Ink smart contract? So how do you use lockable currency from within an Ink smart contract? Okay, so I'm really not that much knowledgeable on
a little bit
on like like Ink stuff. For me, it's like I've never really done anything more than like the basics, so I wouldn't know.
So the very high level overview is go into the Ink docs and you're going to find chain extensions. And what this chain extension allows you to do is interface your contract with pallet logic. So it's the coupling in between there. So effectively, it's another way to loosely couple. You can have a fixed forever, hopefully, right? There's some really bad things that can happen if this breaks. Interface between what contracts are expecting to see on the pallet side. So you can interact with, like, I want you to lock this particular asset on this particular pallet. Yeah, so that's definitely possible through chain extensions.
Cool. Yeah, great. That's a great answer. So what's a good practice to deal with different versions of pallets dependencies when they are not called from a crate in development?
This is a hard one. So actually, we had a little team meeting about versioning in Substrate, and this story might be changing. But for now, the absolute best way to do it is to have everything uniformly match one particular commit of Substrate. So like, for instance, in the developer tutorials that we have available, these are almost all based on a specific monthly tag of Substrate. So when I'm looking through this, I'm looking for that upstream, the dependency I'm calling in my cargo.toml is the GitHub, right, to Substrate. And then specifically, I'm using the tag monthly, whatever it is. When you're using outside things like ORML, they may or may not be compatible. So if things are broken, this is a great chance to go and make a contribution, I would say. There's probably only minor tweaks that need to happen on the ORML side to make it compliant with this particular version. And I would go to ORML and check out what is compatible at what point. And depending on what your needs are, it's which would be more work, trying to maintain the version history for Substrate specifically, which I think is much easier, or ORML and try and stick to what they're doing and then use whatever you need from Substrate. So the too long didn't read, don't mix versions. Use all the same Substrate version.
Yeah, you'll run into trouble. Hi, I wanted to ask customized frame palette functionality. Yeah, this is an approach. Like, yeah, I want to touch on this, but I want to go through this thing first. So, okay, this question is probably something that a lot of people wonder about. I'll read it, and I'm sure Dan knows it better. Is it necessary to use the nightly builds of Rust for Substrate development?
So the answer is yes, but not for all of Substrate. It's only for the runtime. And specifically, we need it. There's an open issue on, I think, Rust or Wasm, somewhere in there. You cannot build with the Wasm target with the stable compiler right now, at least how we're using it. So if you want to build a runtime in Wasm, which is one of the core tenets of what makes Substrate so powerful to have this runtime as its own independent Wasm blob, you got to use Nightly. And that's becoming less true soon. So soon it'll all be stable.
Mm-hmm. Well, you know what? I'm going to answer this question. So the reason I wanted to keep it to the end is like, once we kind of go over like how we're using these things, like then the question becomes like, what else can I do, right?
So what's the question?
The question is, hi, I wanted to ask if I want to customize frame palette functionality, then how do I approach it? When should I copy the functionality needed into my own palette versus inherit from a frame palette versus use custom adapter structs to extend the functionality? Is there any other way you do this? It's a great question. It's actually not one question. It's a lot of questions, but I will answer like at least what comes to mind.
Yeah.
So yeah, huh?
No, sorry.
Yeah. So you want to customize frame palette functionality. So Frame gives you a lot of the tools to do like heavy lifting things, such as you can use an existing Frame palette that gives you access to like having a currency over your system, like out of the box, and you can just kind of use that, and your blockchain will have a uniform understanding of currency. That's like why one would maybe use these things that already exist. When you want to copy functionality needed, I think every use case will be different, and you will want to tweak whatever. Maybe you are doing something similar to the staking palette, and you're using that as an example, but you'd likely really be more use case driven for your particular business application, and you'll likely need to be tweaking things. So it's just more of a a lot of this code exists and is a great sort of example of how things can be done. But the reality with Substrate is that there's so many different ways that you can accomplish that same thing.
As I'm reading this question, I think I understand it more like what we're about to get into is this difference between tightly and loosely coupling pallets. So if you want to extend one of the pallets that exists in the frame stuff that's on Substrate, then it's probably what you're after is what you're talking about, extensions, right? Is a loosely coupled pallet. You would like to, for instance, extend some little tweaks to the balances palette in some particular way, but you want to use it as core. But as you as a developer, you can make a decision, no, like that's too weird. I don't want to build an abstraction on top of it. I just want to copy paste and edit the stuff that I need in my particular runtime. And as far as I understand, it's going to be roughly the same in the end. In fact, it might be more optimal for your specific runtime. The thing that you'll lose, though, is that, especially in the loosely coupled context, ability to change that functionality over time. So like, for instance, the balances palette is probably a bad example, but some of these frame palettes get upgraded over time, right? They get optimized and improved in some way. And that abstraction, you're going to miss out on whatever is coming from downstream. So if you want to build something super custom and you're not so worried about having some of that extra functionality and powerhouse that Parity is hoping to bring into the party for making things better over time, then yeah, of course, just copy paste and use it as you see fit.
Sweet. Okay, so let's rock and roll here.
I'll say done.
Oh yeah, done answering. Okay, so this is kind of where we all wanted to arrive, and I wanted to sort of. So actually, like this is what I did. I have all my commits here, and I want to go over them with you guys, right? So and kind of like we've touched on a lot of things, and like I'm hoping that we're kind of going to bring things together with these commits. There's only how many of them? 3, 4, 5. There's only 6 of them.
Yeah.
And
but
so
what are we based on? What is this?
Okay, yeah, let's start there. So let me start there. I'm going to quit all this stuff. I'm going to take care of this. So we have a clean slate.
So this is our Substrate node template that comes out of the developer hub, right?
Yeah, yes.
So this is the standalone template that otherwise you would have to find in the big Substrate repo.
And if I go runtime, I can see that it's the monthly tag is.
So that's what we were talking about earlier. Is
Yeah.
the Git upstream and use the same tag for everything that touches that Git repo.
Yeah, like you said, I just this is a branch of this monthly latest, and you can see like this is where I I want to go to the commits like I had before.
Oh, you were right. Yeah, go back to the timeline. Yeah, back to the collapse the outline. There you go. And now where the home page equals something is 2. One more up. There you go. Okay. Yep. This is the base template. This is the last change that happened on the base template. And then 2 hours ago, you made this other one, right?
Right. Yeah. So yeah, it's just like, oh yeah, this is
perfect.
So okay, we're back to so yeah. So this is so. I didn't sort of rename this palette anything special, right? Because basically what I'm gonna go through is just the commits within this template palette. So the template palette like already exists, right?
So this is the easiest way to start because you don't have to think about how do you construct the palette based template. There's a template. Why don't we just start writing in it?
Exactly. So like this last commit 3 weeks ago is when we released our new docs and we had to make this. So you can see that that's the commit that represents like 3 weeks ago. And really what I'm trying to show you guys is that this is just a template palette. So template palette, for those that like aren't familiar, it uses all of these macros that we've been talking about, right? This talk is about these palette fundamentals. And these fundamentals are, using these attribute macros that allow us to do this basics. Really, what it is, it's basic things that allow us to communicate with our runtime, and then from that our node, etc. So what the first thing I did is I want to use the lockable currency trait, right? So I need to import it. So lockable currency comes from frame support. Like you can see if you go to the Rust docs. But there's also a bunch of things that we need that we'll see. And this is everything that's highlighted there. So if you go to the docs, you'll notice that lockable currency requires a lock identifier, and also the functions within that trait require this thing called withdraw reasons. So the next thing I did was I declared this constant because the lockable currency needs, and actually this is probably going to be less clear without me actually going to the Rust doc, so I will. So we need this lock identifier, and then we also need to create a balance handler. But real quick, so what are we going to look at here? If I go lockable currency, and I really invite you guys to follow along with me. It's really just a great way to learn. So we've got, we're going to be using all of these functions. So we need, the associated types. So that's lock identifier, and then withdraw reasons this other one. I hope that makes more sense. I'm just trying to make it be super clear. So then the second thing we did here is create this balance of handler. And what this does is kind of interesting, right? It's really like using sort of this generic and trait system that Rust gives us. Dan, you explained it pretty well when we were chatting before. But basically, this balances of is basically it's bound by this trait, and we want it to get access to this balances or this balance type in the configuration trait of frame system. So what it allows us to do is to what we're doing here is we're creating a type that allows our palette here to speak the same language of currency with other palettes, right? And that's kind of how I think about it. It's really like, how can this type sort of be easily sort of, it can interact and understand another concept of pallet of currency that maybe another pallet has. So the second thing we're doing here, or the third thing I guess at this point, is in our configuration trait. So this is like the kind of like the core of a pallet, right? Where we define the configurable types. And I created this type called currency. And we changed this later, but for now it's called currency. That's going to be confusing, actually. We now, like you'll see in the last commit, it's changed to locked currency so that it's less confusing. But so whatever, this type, it could be anything. It could say anything. The fact that it says currency has nothing to do with anything external to this palette.
Right. But so what we're defining here, right, is the interface that the runtime will concretely specify. So currency in this case is an abstract concept that has these traits, specifically the trait lockable currency.
Yes, exactly. So when we look at our docs, this is like this lockable currency is if you go back here, lockable currency, it's in currency.
Mm-hmm. And the lockable would be under
currency in here. So yeah, so these traits are what we're talking about. And what did I want to show? Yeah, lockable currency. Yeah. Okay.
So specifically showing there's different ways you can configure a currency and different traits. So basically describing what kind of currency you would like. Abstractly, we know what currencies are, and a little bit less abstractly, we're saying, is it a lockable currency or a named reservable currency, right? And I don't know, can we mix and match these? Or is it you select one of these traits?
I think that you can you can mix and match them because they are implementations they provide interfaces for like the overall currency module here.
And this makes a lot of sense to pick one in this particular case, right? And because we just want to be reasoning about locking currencies, right?
Yeah, exactly.
And as a matter of fact, I think you do need to mix and match, right? Because setting lock, extending lock, and removing lock, that's only applicable to what we're trying to reason about right here. Whereas currency in general is a lot bigger than just locks, right? So absolutely.
Exactly. So yeah, basically the takeaway here is we declared this type, and we are bounding it to lockable currency. So then the next commit here, if I go on the bottom left, what I did is I actually just implemented the function here.
Because these traits, we need to implement these, otherwise the cargo is going to get real mad at us, right?
Well, look, no, actually, that's the beauty of loosely coupling, not necessarily, right? Right? Like I didn't need to implement any of it really. Well, no, it wouldn't be my configuration trait if for no reason. But the point I'm trying to make here is I'm just creating this function that's publicly dispatchable, like publicly accessible. It's called lock capital, but it's using the trait, the currency trait that I specified in my type. So this currency set lock really is coming from all the way up into my first commit where I declared currency here, and I have access to set lock from specifying the.
So this is actually auto implemented for us. Is that what you're saying?
We have access to it, right? Yeah. Because we are passing in to the configuration trait of our palette this new notion of currency, really, we're calling it, right? And so this is a very, like, when you kind of understand, like, how things are sort of wired up, you can sort of leverage these to however your use case is. So what's the, so yeah, and then I put an event here, right? Because this function, it emits a locked event. But all this is doing is that it's ensuring some origin, it's setting the lock, and then emitting an event. So if I go up to this, it's same pattern, exactly the same pattern. Here, the first thing we see is the event that I'm defining. And so notice in the locked, actually, the balance of, the use of balance of, right? We need there needs to be an understanding of like the balance that that this currency trait, which is lockable, understands, right? So we need to respect that, right? This amount here, it's of type balance of, which is customized, and it's really just what we define in our palette, but we bound it by these traits. And if we look, we can probably find in the documentation that this is going to be very similar in terms of what it requires to the this balance, right? So if I go here, this is probably just a bigger abstraction of what balance can handle. But this designates the balance of an account. And here we've jumped to.
And I think the abstraction, if we go back to your code, looking at this, effectively, this is how we're casting in a global concrete instance of this stuff, right? So we're setting, we know that you want to balance, but what balance and where and how do you want to actually concretely interact with it? So balance of, right, I think is a good name for this, because we're reasoning about the balance of a particular account, right, that exists here concretely in our system, as opposed to abstractly with just balance.
Yeah. This line of code is a lot of things, right? But it really like narrows or very specifically defines what kind of currency. And when we do lock currencies, and we can do a demo, but maybe we might not have time. But I invite you guys to run this code, and when you lock currency, then check the balances palette, and the balances palette gives us the ability to see if there's any locked funds in our system. And if you do it correctly, you lock funds, you will see that in the balances palette, it'll say those funds are locked there. And that's what's kind of working under the hood, right? Because we haven't gotten there yet, but this palette, when we've added this currency type, what it takes in from the runtime is balances, but balances from the balances palette. So if I go to, this commit, balance of is a super interesting thing, and a very useful tool, right? Like you can customize like account ID members, like you can use it for currencies, for I don't know, basically this pattern of bounding your type is very useful and powerful. So balance of, and here I'm just extend log. So that's the third one. I thought, may as well implement it. I actually did this 4 hours ago, in the sense like we only had 2 and we might as well put them all, but it also shows, we don't need to have them all, right?
Makes sense.
So same pattern, right? Okay, so rename. Here I renamed it because lock currencies were intuitive, right? It's maybe misleading that you guys might think there's multiple like instances of currency here, like what's this, right? So
using the same name for a bunch of different things can be confusing sometimes.
And so so let's go into the runtime folder and just kind of come full circle here.
So now our pallet's been all implemented. We've got this lockable currency trait that we've implemented, right, in this palette. And then we've given it this abstract notion of what the currency it should be applying to. And now we need to somehow tell at a high level concretely what are we reasoning about. And this is happening in the runtime, right?
Yeah. So Ignore this for now because I will actually, like, why not? So this special account ID is this last thing that I wanted to add with regards to adding a special origin. And it's not an origin in the way that Frame understands and knows origins. It really is just specifying a key where only from which only that account can make the call. So in this sense, I'm just trying to demonstrate how we can use the notion of like giving access with just a key, but really, like, it would be fun to have to see any of you like take that concept and turn it into using origins where so basically, like, if I
can get back to that, let's get back on the locked currency.
So okay, but it all connects. So this locked currency thing, this is like if you look at what's happening here, we're passing in balances into locked currencies. And so the balances is from the balances palette that is in our construct runtime here. And what that means that in the runtime, we've configured this really is in some way like, configuring. There's a how-to guide on configurable constants, but this is really just like configuring, your runtime types, your config types in the runtime, where this could be maybe some other thing that does balances in our system. The Open Runtime Module Library has its own currency thing. In my slides, I put that in the comments. You can check that out. Like, what if you use that for balances? But all we need to respect is what we've defined as this type in our palette config trait. Cool. And right now it's balances. And what's cool is that, when we do lock currencies, when we do lock some amount from this palette, the balances palette will it is information that is shared and that is known and that is acted on by the balances palette too.
So effectively, we're passing in now in a concrete way. The balances palette is the thing that we're reasoning about that has all these traits and things in lockable currency.
Yeah. Cool. So that's kind of it, really. Like the different commits in the runtime file, which is what we're looking at, are less, right? Because we so the first thing we did in the runtime librs file is added this balances, and then I changed the name, and then so this is the special account ID thing. So the last thing I want to show, and I think we can kind of wrap up or take these questions, is that inside of my palette, so this is what we're talking about when like this special account ID thing, right? So in the runtime, you saw it. I gave it a special key. That means only that key can make dispatchables, but not just out of the blue. No, I have to code it, right? So if I show you what that would look like, essentially what I've specified here, and again I'm using like primitives and I'm trying to just show you guys the patterns. Well, in this Lockable function, I ensure that the caller of this dispatchable is of special account ID, and if it isn't, I throw an error. I throw a bad origin error. That's it. Like, just to kind of like tie two concepts together.
So I guess this is kind of a cool narrative. Maybe we can leave it as like a fun exercise if you guys want to dive into it. Is this branch you're sharing, right?
Yeah.
So we've got this lockable currency shell, right? And effectively, we're implementing this extra functionality to do some lock, but it's pretty basic. Like literally, it's just lock and unlock this stuff, right? But now we're adding this idea of we can have a particular account, for instance, have the ability to lock capital. So out of everyone that exists in the universe, just this one key is allowed to do a specific thing. So dreaming up like what might that be? Like what master control do we want to have over locking capital? And I don't think it's implemented. Do we have a way to unlock capital?
So
from the special account?
That's interesting. Nope.
So this one key,
which doesn't make sense, right? Obviously, like I should have done that.
Work in progress. But so this is a really interesting thing to bring up, is that in your runtime being very careful about these logic bugs, right? Because you can actually shoot yourself in the foot about a lot of this stuff, you know?
Yeah.
But here it'd be, maybe you guys want to play around with it. What would you do with a lockable currency from a particular account and being able to check that it's always just this one account making things happen?
Cool. So what do we have in the chat? Anything?
In there? Yeah, I don't know. I just want to thank you, Sacha, for giving me this run through, and hopefully you guys found it useful too. I know I'm still just a novice, a Padawan, and I see someone in the troll box. I was probably saying stuff that was stupid, so I'm growing and learning too. And I'm glad to be here on this journey with y'all.
Yeah, Will says cargo watch can be handy as well. Definitely.
Cool. Yeah. Good pro tips.
Yeah, what's kind of last words here? I mean, again, like this seminar was sort of more geared to the hackathon happening. We are here to help you guys. If you have any questions, I think you know how to find us on Discord. Mm-hmm. And I will leave like with a few last words on like, there's a lot of cool tools out there available. When you're building your solution, especially for like a hackathon, I think the first thing is to get to the drawing board on what am I trying to do, and the sort of then the how to accomplish it becomes much easier, because instead of just kind of randomly trying these cool things that we looked over today, well, you know exactly what you're looking for. So that would be my word of advice. And yeah, like happy hacking.
Yeah, have fun, guys.
Cool.